think this is the thing for you.
A final year BTech student at IIT Madras. I am also the CEO and co-founder of the E-Plane company.
I've chosen this institute because it is one of the top leading institutions in India.
Academics is something which is the most important thing at IIT Madras.
One of the most prominent sections of my institute life is doing courses. I have done courses right from sociology to history to politics and as well as in finance.
Whatever you study here, you feel it's, there is a lot to learn in that field and there is a lot which can come out of that field.
The student in IIT Madras has given the opportunity to consult with industries as well as do research work.
We also want to then start working on electric air taxis in about 1 or 2 years' time.
Here in IIT, the best thing is you can actually know whether you are passionate about this or not, because you'll have the time and also opportunity to explore each and everything.
Despite being a business student over here in IIT Madras, the uniqueness over other B schools in India is that I get to network over with the people with other departments as well.
It is no wonder that in the last 5 years, the major technology startups that have made headlines in India are from IIT Madras.
It's a great place for students to enhance their learning.
Department of Management Studies, we started in the year 2004, and we are a good 15-year-old department, and we are growing as of now.
One of the things we've been involved in is an executive MBA program, which is meant for people with a lot of experience, a huge amount of peer learning that's involved, because the batch size is quite diverse.
DOMS IIT Madras has the culture of working closely with the industry, which enables nurturing leaders and entrepreneurs through a holistic and grounded learning experience.
We are extremely privileged to be collaborating with the other departments of this technical institution. We typically do courses in departments such as computer science, electrical engineering, humanities, and social science.
Technology bridged with business management, Tech MBA. This is first time in the history of IITs that we have started something like a Tech MBA program.
We also have government-funded projects which help the scholars in contributing towards building a better nation.
We're proud to say that many of our MBA students in the earlier batches have reached the CXO level as of now.
The Institute of Eminence scheme has been launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutions. IIT Madras is proud to have been selected as one of the select institutes of excellence. As part of our commitment to the cause of fostering world-class research, IIT Madras has set up a number of research initiatives in diverse fields of contemporary relevance. Many of these initiatives will go on to become centers of excellence within the IIT Madras system. A total of
Thank you, Shivram, for the lovely videos that you're playing in the start of every webinar. So, hello and good day to everyone. Thank you for joining us today. This is Rudra from the Office of Global Engagement, IIT Madras. It's my pleasure to welcome you all to the 53rd webinar from the IRIS webinar series. So the Institute of Eminence scheme was launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutes. IIT Madras is proud to have been selected as one such Institute of Eminence. So a total of 68 research initiatives belonging to 21 identified cluster are presently underway at IIT Madras. So as a part of these initiatives, the IRIS webinar series aims to showcase the innovative research that is being generated to various stakeholders like students, researchers, industrialists, and policymakers. So from the Earth Science Technology Cluster, this research initiative that we are presenting today is titled Subsurface Mechanics and Geo-Energy, led by Professor Chandrasekhar. So the research at Laboratory for Subsurface Mechanics and Geo-Energy is primarily focused on the fundamental understanding of thermo-hydro-chemo mechanically coupled subsurface processes. So through this knowledge, subsurface system will be engineered to efficiently extract geo-energy while mitigating adverse environmental impacts. So to introduce Professor Chandrasekhar, who is the principal investigator of this research initiative. So Dr. Chandrasekhar Annavarapu is an assistant professor in the Department of Civil Engineering at IIT Madras. He worked as a scientist at the Lawrence Livermore National Laboratory, the Department of Energy Research Facility in Livermore, USA. He also worked as the ExxonMobil Upstream Research Company in Houston, USA, as a computational scientist. So Dr. Chandrasekhar research expertise in the computational mechanics. His research focuses on addressing the limitation of finite element methods for complex and evolving interface problems in mechanics, such as crack surfaces and material boundaries, and also advancing numerical algorithms to the model the process of hydraulic fracturing as a multi-physics processor. So thank you for being with us today, Professor Chandrasekhar. It's my pleasure to introduce the moderator for the webinar today, Professor Derek Ellsworth. Professor Ellsworth is a professor in the Department of Energy and Mineral Engineering and Geosciences at the Center for Geomechanics, Geofluids, and Geohazards at Penn State. His interests are in the areas of computational mechanics, rock mechanics, and in the mechanical and transport characteristics of fractured rocks, with application to geothermal energy, the deep geological sequestration of radioactive wastes and CO2, unconventional hydrocarbons, including coal gas, tight gas shales, and hydrates. So he was selected as the United States National Academy of Engineering for his outstanding contribution to understanding the natural process affecting flow and the transport properties of fractured rocks. So thank you for joining us today, Professor Derek. We are excited that you could be a part of the session. So we also have a very distinguished panel with the faculty from across various departments at IIT Madras. So we have Professor Ramesh Kannan Kandaswamy, Professor Jitendra Sangwai, Professor Abhijit Chaudhary, who are also the co-PI leading this initiative along with Professor Chandrasekhar. So before we start, a note to the participants, please use Q&A box to enter your question and upload the question that may interest you so that the moderator can prioritize them. Over to you, Professor Chandrasekhar.
Yeah, thank you, Rudra. Let me share my screen. Okay, so I hope you can see my screen now.
Yes, Professor. Yes, we can.
Okay, perfect. So thank you very much, Rudra, for the kind introduction. It is indeed a pleasure for me to speak at the IIT Madras Research Initiative Spotlight Series. And I welcome all the participants for today's webinar on the Subsurface Mechanics and Geo-Energy Group. I would also like to thank Professor Derek Ellsworth for taking the time to moderate our webinar and the following Q&A session. Okay, so I'd like to begin by acknowledging our Subsurface Mechanics and Geo-Energy research team. So we are a group of 14 faculty members, all based at IIT Madras. But because Subsurface Mechanics and Geo-Energy is a highly interdisciplinary space, our affiliations are spread across multiple departments, including the Department of Civil Engineering, Department of Chemical Engineering, and Department of Applied Mechanics. So although the individual subject matter expertise varies, collectively as a group, we are all focused on understanding the physics of the subsurface and their applications in the geoenergy space. So before I proceed further, let me lay the groundwork for why we believe that this research initiative is important. So on this slide, what you see is an animated bar chart race, which looks at the historical evolution of the top 10 energy consuming countries, beginning from 1965 all the way to 2020. So before I discuss this further, let me play the animation for you. Okay, so as you can see from the chart, the energy consumption strongly mirrors the size of the relative economies, and this was true as true in 1965 as it is today. So 1965, the decades of 1960s were the Cold War era. So you typically saw United States and USSR leading the charts. Then we saw the rise of Japan in the 1970s and 80s. And China opened up its economy in 1979, and it has been figuring on this leaderboard ever since then. And the same with India. In 1991, we opened our markets up to the rest of the world by liberalizing our economy. And we have been constantly rising up this chart. So this comparison is even more stark when we look at these figures side by side. So on the left, we have the top 10 energy consuming countries, a snapshot in 2018. And on the right, we have the relative size of the economies measured in terms of the gross domestic product adjusted for purchasing power parity. So we see all the usual suspects in both the plots. We have China, the United States, India, Russia, Japan, Germany. So there is a remarkable similarity between the two charts. And what we can say is that economic progress and energy consumption are strongly correlated. When we consider the emerging markets, such as the BRIC countries, Brazil, Russia, India, and China, their energy needs are only going to grow because these countries continue to grow rapidly as they make their transition from middle to low income countries to high income countries. And when we talk about energy, geo-energy especially, often we think only about the fuel that we need to power our internal combustion engines, but it's not true. In order to get a holistic vision, we also need to look at electricity consumption, because we also need means to generate this electricity. And once again, what we see is that as we move from the low income bracket in per capita income to the high income group, the average annual electricity consumption per head is also increasing. So what we see is essentially that this is a case of competing priorities. On the one hand, we want that economic prosperity should be uniform, right? So it should be all the countries that are in the low income group should move towards the high income group. On the other hand, to do that, we need to provide for their growing energy appetite. And we need to do that without placing any undue burden on our planet. As we can see in the last few years, anthropogenic climate change has disastrous consequences. So while these concerns are truly global, they are also especially important in the Indian context. As I already discussed, India accounts for a major share of the global energy demand, quarter of it to be precise. And we are also an aspirational nation of young people. So there is a rapidly increasing middle class population, which means that we have an increased demand for electricity, transportation, infrastructure. In fact, if we grow at the current rate, we are expected it's projected that our energy requirements will be doubling by 2040. But having known all of this, to this day, our energy requirements are primarily met by coal. So even among the group of fossil fuels, coal is among the worst of the lot. So there is a strong need for diversification, and natural gas could provide a good alternative. So while we are developing the infrastructure for the classical renewable energy sources such as wind and solar, natural gas could be a good transitory fuel because it's much cleaner than coal. And in addition, we also need to think about energy self-reliance, because our nation has a very high energy import bill. So we need to increase domestic production of natural gas from unconventional hydrocarbon reservoirs, as well as from methane gas hydrates. In addition, when we talk about renewable energies, oftentimes we don't think about geothermal energy, which is a highly potent clean source of energy. And we need to think about harnessing this source to power our nation as well. And finally, while we are making this transition, it is inevitable that we'll be releasing greenhouse gases into the atmosphere. So we need to think about developing technologies that would mitigate any adverse environmental impact by geosequestering the CO2 that we're releasing into the atmosphere. In terms of the potential that India has for domestic production of natural gas, as per the United States Energy Information Administration report in 2015, India has a technically recoverable resource potential of 96 trillion cubic feet. And this is mostly confined to the Cambay Basin, the Krishna Godavari Basin, and the Gondwana Basin. And to put it in perspective, if the current demand stays, then 96 trillion cubic feet of natural gas can power our nation for 2 decades. And when it comes to domestic production potential from gas hydrates, once again, the technically recoverable resources are pegged at 100 to 130 trillion cubic feet, and they are mostly found in the Krishna Godavari Basin. And finally, when it comes to the potential of geothermal energy in India, as per the Ministry of New and Renewable Energy, we have a potential of 10 gigawatts in the northeastern region, as well as in the Sonata region and the Godavari Basin. And in fact, pilot projects are already underway by state-run Oil and Natural Gas Corporation, as well as Singareni Collieries Company Limited in Ladakh and Telangana, respectively. So that brings us to why we believe that this center is essential. So in our opinion, it's one of the defining challenges of our time to sustainably address the energy demands of a rapidly industrializing world in general and our nation in particular. And we believe that this can only be made possible through the creation of fundamental scientific knowledge and technological solutions in the geoenergy space. And because the problem is so vast and challenging, we cannot do it alone. Of course, we need to collaborate with leading academic universities and private corporations around the world to leverage complementary expertise and develop technologies which will allow us to extract unconventional hydrocarbons and geothermal energy in an economically viable manner, as well as geosequester carbon dioxide. So at this point, I would like to invite my colleague, Professor Ramesh Kannan, to take it forward from here and discuss the center's objectives and activities.
Thanks, Professor Chandra, for clearly explaining the motivation behind establishing the center. So it's pretty obvious that we need to move away from the conventional sources of energy. In order to do so, we need to be equipped with the latest technologies in order to efficiently extract the reserves. So, however, it's a bit challenging because of the complexities which are commonly observed in a subsurface geological structure. So, as you can see on the slide, this is a simplified schematic of the various, which will show you the glimpse of various complexities involved in subsurface energy extraction. So you can, as you can see, there is regions of overpressure, which you will commonly observe near the fluid-filled sediments where the core pressures are really high, which eventually results in blowout of these wellbores. Further, we also encounter certain problems associated with wellbore instability due to the high stresses that you will commonly encounter, and also due to the poor strength of the rock in certain part of the reservoir. The other common problem that you commonly encounter is the lost circulation, which happens when you start pumping the drilling fluid into these bore wells. It gets lost in these depleted regions, and it's very hard to efficiently extract the results. In addition to all these problems, we also have problems associated with hydraulic fracturing and also the fault reactivation, sand production, especially when you're actually extracting the reserves. There are problems associated with sand production, and coupled process of the fluid flow and the temperature, which eventually causes mechanical changes, resulting in subsidence of the ground surface. Right? So with respect to all these complexities, it's extremely hard to efficiently extract these reserves, and also this results in production delays and associated cost increase. So Chandra, can you please move on to the next slide? So in order to tackle this problem, our center has taken an integrated approach where we start from the reservoir characterization, which is followed by the geochemistry, experimental mechanics, computational mechanics, and finally the field exploration. Chandra, can you please move on to the next slide? Thank you. So as you can see, there are 5 verticals or subcenters that is associated with the center. Each vertical will be tackling specific tasks in order to achieve the overarching goal of this center. Under reservoir characterization, so the subsurface shear wave velocity profiles will be obtained using wave propagation techniques and also using advanced surrogate models. Under geochemistry, studies will be carried out to understand efficient CO2 sequestration, usage of CO2 as a fracking fluid, and also using uncertainty quantification for multi-scale models. In case of experimental mechanics laboratory, studies will be carried out for a comprehensive characterization of hydrate-bearing sediments, which will be useful in developing thermohydromechanical models, which in turn will be useful in quantifying the subsidence that occurs during energy extraction. With respect to the computational mechanics lab, it will be predominantly involved in developing novel algorithms in order to predict the fracture propagation in this complex heterogeneous reservoirs, and also develop coupled models for the enhanced geothermal system. Finally, with all the knowledge which we gain from these verticals, we will be using it in the field with the help of our industry partners. So in order to achieve the goals, which we mentioned it in the previous slide, each subcenter are in the process of establishing some of the state-of-the-art facilities at IIT Madras. So for example, a high pressure temperature controlled triaxial apparatus will be used in order to comprehensively characterize gas hydrate sediments. Also, low frequency non-destructive testing using MASW will be used to characterize the reservoirs, and also the enhanced oil recovery setup, mass spectrometers, high pressure reactors will be used. Further, we are in the process of establishing a high performance computing facility, which will be useful in solving complex geomechanics problems. At this point, I would like to thank IIT Madras for providing us with an opportunity to establish this research initiative. And as a part of this center, we are already actively collaborating with some of the universities across the world. For example, UPC Barcelona, Monash University, University of Cambridge, and IIT Hyderabad. Additionally, we are also working closely with national laboratories like Lawrence Livermore and industry partners like ExxonMobil. Currently, we are also in the process of establishing collaborations with the University of Minnesota and UIUC. So as a part of the center activities, we recently organized a weekly webinar series by inviting some of the leading experts in academia and industry. So we got an anonymous positive response from the graduate students from India, also from abroad. And we are also planning to conduct this webinar series, the second edition of this webinar series next year. So please watch out for the notification in the website given below. Also, we are in the process of inviting some of the leading researchers to this center at IIT Madras next year, where we will be organizing some short courses and workshops. So please look into our website for future notifications. Additionally, any students who are interested in applying for internships or MS PhD programs, postdoctoral position, please write to us in the email link given below. Right. So finally, I would like to tender an open invite to all the interested students, researchers, and industry colleagues to actively take part in the center's activities in order to develop indigenous technology, which will be helpful for a self-reliant in India towards energy security. Thank you. So I'd be happy to take any questions. At this point of time, I'd like to hand over to Professor Chandra and Professor Derek in order to start this Q&A session. Thank you.
Yeah, thank you, Professor Ramesh. So yeah, as Ramesh mentioned, we'll be very happy to answer any questions. So Professor Derek, if you would like to lead the Q&A session.
Okay, I'll be happy to do that. I think my microphone is unmuted. Thank you very much, Pranashekar and Ramesh, for your presentations. It looks like a very interesting center you have, and it looks as if it's off to a good start with the webinar series that you've had. One of the good things, maybe perhaps one of the only good things to come out of COVID is our adoption of Zoom, where it brings us together internationally much more easily and much more naturally than we ever used to do. Will there be any questions that come up on the chat? I see a whole bunch of questions in the Q&A, but most of them were kind of live stream of consciousness questions. But I can read from the base of some of them. Don't put them on too quickly because they'll move up through the screen. If I look here as they're moving, as I do it, actually they move quite quickly, don't they? Chandrasekhar, what's your view currently? I'll take Chairman's prerogative and ask a question first. What do you see as being the outlook for India in terms of research developing in terms of these two competing goals that you mentioned so eloquently in your first part? The desire to grow an economy where clearly GDP per capita earnings, if you like, is related to per capita energy consumption. And typically in all countries around the world, certainly most of them anyway, that's related to fossil fuel usage. So GDP per person or earnings per person is also linked to CO2 per person. So clearly dealing with the needs of a growing country, plus the needs of global climate control and carbon neutral fuels. Where does India sit in terms of being able to sponsor technologies that balance those two components?
So as I see it, it seems to me like there is an urgency, at least at the leadership level, that we are appreciating that we cannot do what has been happening in the past, let's say 100 years and take the same path for growth. So we are making a conscious effort to develop energy resources which will help us also limit the environmental impact, because as you can see, I mean, maybe in the past decade when we were growing, Indian cities, for example, Delhi, the impacts were clearly felt by the population. So it was not an abstract thing anymore. The PM 2.5 particulate matter in the air quality was felt. People were finding it difficult to breathe. So I think at the policy making level, there is clearly an urgency, and I hope that this translates into us sort of taking a leap where we are not going to follow the traditional path. So for example, when you looked at telecommunication and you go to Africa, they've completely skipped landlines, right? So in the same way, maybe we will be able to skip over some of the more traditional ways of developing energy. But at the same time, I think there is also this priority that this cannot happen at the cost of development. So people want to move up the ladder, right? So they want to move from one segment of the society to another. So I think I'm hopeful. I could just say that I'm hopeful, and we are moving forward along that direction. What exactly the path we will take, I think this we are going to find out only a decade from now. But yeah, but it seems like we're on the right track.
Yeah, I think that's a great answer. And your point about Africa skipping over landlines, I remember traveling to China in 1994. And from 1990, where my host rode his bicycle to the train station to book the train, 1994, there were all these landlines strung between buildings. and then 10 years later, cell phones completely swamped the market. So do you think that gas shales, this as a bridging fuel, will be a technology that will be skipped in India? Where is the development of gas shales in India right now?
So it's being explored because, like I said, we derive a lot of our energy from coal, which is really worse even than shale gas. So it's been explored. And as I said, in 2015, there was an estimate made by the US Energy Information Administration. And technically recoverable resources at 96 trillion cubic feet, but that's not necessarily the economically recoverable resource. So, there's a lot of learning we can take from the United States on how to recover these things in an economically viable manner. But at the same time, maybe it doesn't translate directly. For example, we are a nation which also has scarcity of fresh water. So whether we can use that amount of water and inject into the subsurface is anybody's guess. So I think that is why I think it is important that we do research in that area and develop some technologies and scientific solutions which can inform the policymakers rather than just following another country's path.
No, I agree. That's the conundrum for China, I think. Their gas shales are much more brittle than the US ones, much weaker. And also for them, water is a big issue. And so that causes them. So some of the other questions that I read here. One question about, you didn't talk about nuclear power. And of course, that relates to the subsurface in recovering uranium, but also it is a central theme in terms of disposal of high-level waste. Where does that stand in India? Obviously, India is a nuclear power and therefore has nuclear power. What is the status of nuclear energy for the future in India?
I would maybe pass on this question to someone else on the panel because this is something that I'm not aware of. Maybe Professor Tyagaraja, if he's around, he was working with the nuclear power authorities in India. Professor Tyagaraja, are you around?
Okay, well, maybe if
Chandra, I think Professor Dali Naidu can answer.
Okay,
he works on Dali. Can you?
Yeah. Am I audible?
Yes, you are.
Yeah. Thank you, Professor Chandra and Professor Derek. Since majority of our energy resources are coming from the conventional coal and then other things, still in India we do have less than 8 to 9% of energy is coming from the kind of a atomic power. So at this point of time, our main focus is on the increasing that fraction towards the sorry. Sorry,
is someone unmuted who should be muted?
Am I audible?
Yes, you are.
Yeah, you are.
Yeah, sorry for that. And then since we are growing towards improving the energy from the atomic power, and then I think even if it's reaching a 20% is really great mark. But however, a lot of downstream side effects we need to really address it. People are really working on how to design a DGR and then how to locate a DGR and what kind of a location is really best suitable for. And some kind of a field experiments have been investigated, have been studied to identify the site. Still there in the experimental, situation. So I think that area will grow further. So this is what.
Yeah, certainly I presume that nuclear power is certainly a very viable way to produce energy in the future and quite clean in terms of carbon. And in terms of accidents and environmental dangers, I think it's been shown to be much less risky than, for instance, hydroelectric dam generation, which often fail. So another question here is related to what's the status of geothermal energy in India. Certainly, the Himalayas would make good sense for high heat gradients, perhaps? Where are the main areas? Is there currently a geothermal industry in India, and what are the prospects?
It's very nascent. Abhijit, would you like to answer, since you're, the resident expert in that area?
Well, we have geothermal energy. Are seeing the map of India. I mean, geothermal atlas of India. They're in general low to moderate enthalpy. So, but in Himalayan region they are in good, and I think there are some investigation and energy production are happening. Research anyway going on by different groups in different national lab, and some companies like Indian thermal power plant company is also doing some studies in Sonata region. So I mean, yeah, some work is going on, both research as well as exploration, and so far there is no big thing achieved. And I mean, I think I can request Professor Chandra Sekharam, who is here also joined as a panel member, who made the map, can add something to it also.
You're sending the question back to him, are you?
No, I think Professor Chandra Sekharam is other, he's different than me, so the names are similar.
Oh, okay.
Yeah.
Yeah, Professor D. Chandrasekharam, I think you know him. He was there. I don't know. Okay. Okay, no problem. So yeah.
Yeah, I think to give a short answer, I think we are still in the nascent stage here. There is some potential, but nothing concrete has happened in terms of a real impact. So, but it's going to, I think, hopefully it will progress.
Yeah. So here I'll tie two of the questions I see here together. So one question asks, what are the difficulties in geothermal engineering and unconventional resources? And I would suggest that some of them are related to being able to characterize beforehand, especially for geothermal energy, to be able to reduce the risk of production, that you have a dry well or a reservoir that really has no permeability, or you can't make permeability. And the second question to tie that together is, what are the non-invasive techniques to be able to do this ahead of time that the center might get into? So is there a plan? You noted 5 columns in your presentation in terms of interests: modeling, laboratory, physical modeling, computational modeling. I guess maybe the first one was characterization. Was it shear wave splitting analysis, etc.? What methods? What is the center planning to do in terms of reservoir characterization, which is a big question for geothermal energy, of course, and for other underground subsurface energy projects?
Yeah, Professor Tarun, are you available?
Thanks, Chandra. Thanks, Professor Derek. So what we are try to do here is we have limited number of sensors available. So what we want to do, we want to take help of this MSW test. I mean, a couple of people I think asked this question, what is MSW test? So it is a non-destructive type of test. And the number of sensors we can use is really somewhere around 24 to 48. And we can explore till great depth, say 2 kilometers and 3 kilometers, provided we use a proper source. Now, traditional seismic reflection or reflection test to identify that whether there is a reservoir or not. So it takes around 1,000, more than 1,000, like 2,000 kind of channel. So what we try to do here, try to produce the same kind of result with limited number of channels, say 24 or 48. So this is the prime objective of this center. Yeah, over to you, Chandra.
Can I ask what the MASW must be an acronym? What does it stand for?
Sorry, can you repeat? I'm traveling, so I'm not able to hear you properly.
Are you on your phone, in your car?
Yeah.
MASW test. What do the letters stand for? What's M, A, S, and W?
Yeah, so thanks. So the MSW stand for multi-channel analysis of surface wave. So,
okay. So it's seismic method. So can how deep does that penetrate? Does it penetrate the kilometers down to be able to characterize, or is it closer to the surface?
So the MSW is depending upon the surface wave. So as the name suggests, it is going to be confined to the surface, but it is also a dispersive wave. That means if we can generate wave of 1 hertz or less than 1 hertz, it has the potential to travel more than a kilometer depth. So a general thumb rule is lambda by 3 to lambda by 2. And say if a wave of 1 hertz is traveling around, say, 3000 kilometer per second. So roughly we can explore up to 1 kilometer. And if we can catch, say, 0.5 hertz or in extremely low hertz wave, then we can explore. In fact, we are now, as a part of this center, we are now establishing a lab which we're going to have 2 hertz sensor. We cannot go 2 hertz natural frequency. So roughly 2 hertz natural frequency can capture up to 0.2 hertz, 0.3 hertz, and at least in theory. So yeah, we can explore till 1 kilometer of depth. There is a lot of challenges, and we are thinking that we can overcome.
Okay, great. So let me
can I add one more point?
Yep.
Yeah. So yeah, traditionally then MSW being used to explore up to 30 meter of depth. Yes. So in that sense, yeah, it is true, but we think we can extend it to up to 1 kilometer depth. Yeah. Thank you.
Great. Thank you. So as I read another one here, it says, Chandrasekhar, sir, your presentation speech is amazing. So you should get the name of that person, and that person gets an A in the course that they were taking. So here's another interesting question. This person, Robin Anthony, should put a patent out on this. The question is, should we get deep geothermal energy from the ocean? Obviously, you know, one of the big issues in geothermal energy is having water to be able to act as a heat transfer agent and also induce seismicity. So if you put them far away from people where there's lots of water, that's not such a terrible idea. What's your thoughts about that?
That's an interesting idea, but I am not sure whether that is practically implementable, right? I mean, the cost is going to play a role there. We have these, I mean, maybe oil and gas companies, when they start, you know, pivoting like towards geothermal energy. I think there was a recent conference where they talk about pivoting and applying all the skills that they've learned for hydrocarbon extraction into geothermal energy. Maybe they can come with their massive offshore platforms and help us set up these kinds of plants. But otherwise, it's a little bit difficult practically, in my opinion.
Yeah, I think it'd be very expensive. Certainly offshore, deep water recovery of hydrocarbons is expensive, much more expensive than on land. So, but yeah, I think it's kind of a curious idea. What are the problems with geothermal energy recovery? So one person poses, what is the relative merits and demerits compared to a mature technology like wind or solar, for instance? What's someone's perspective on that? Problems of geothermal energy, of course, are one, being able to make the connection. You're not guaranteed that you're able, at least in EGS energy, it's not guaranteed that you're able to make a hydraulic and useful connection that is thermally desired. And induced seismicity would be a second current issue, I guess, major level issue. But how does it compare to wind and solar? Does anyone want to take that question?
Abhijit?
Sorry, I don't have any answer to that.
I would say that geothermal is potentially baseload power, where you can put it in just like a coal thermal power station. You can generate a gigawatt, and you can put that directly into the grid. It's reliable. Wind and solar dispatchability is an issue, right? It only works when the sun shines and when the wind blows. And unless you've got a smart grid, which is deployed worldwide, where you can take energy from where the wind is blowing and the sun is shining at some time and port it to where it's needed somewhere else in the world, then dispatchability is a different issue. But definitely they're
Storage
great.
batteries, I guess, is if we can develop an efficient battery technology, maybe solar energy can be effectively used.
So certainly you, in discussing your center, you talked about all the kinds of things that we all think about in terms of geoenergy: carbon sequestration, gas shales, deep geothermal, nuclear waste disposal. I think gets tagged onto that somehow. But what about other forms of what might be kind of subsurface or surface, certainly geological engineering projects? Like where does hydroelectric power exist in India's view? Is it all built out in the Himalayas already? All the potential sites are used, or does that play part either in your center or in the country's energy portfolio or aspirations?
I guess around 27 to 28% we are contributing from the hydraulic power. Still, we do have some potential, but however, some of the geopolitical issues usually, hinder us to really do those things.
It's in the wrong part of the country, bordering on other countries.
Yeah.
And the water going downstream from there isn't necessarily yours to use, right? Yeah.
So a lot of our rivers are shared with our neighbors, and a lot of times they are in a way that the source can be restricted. So that is also one of the reasons why we have a freshwater scarcity in the country. So I think there is no real answer to that. I think there is no real easy way of resolving these issues, right? So there are 5 rivers, I think. So the state of Punjab, it's named after those, right? So there are 5 rivers. It's a land of 5 rivers, but a lot of them flow both in India and Pakistan, and they are flowing in a way that a lot of times we cannot control where the source of those is. So.
Yeah, and another potential part of India is Northeast India, where there are a lot of potential sites for hydropower plant or hydropower plants, but the demand is very less there. So currently they're working on setting up a few plants, but it is not supply would be enough. I mean, demand is not so much, so it's not going to be effective.
Yeah, well, certainly dam building is not really in favor now. It's one of those transitional methods. Certainly in the US, they're beginning to take out dams, and certainly you hear of other countries like the Mekong, which I guess discharges through Vietnam, that the amount of water that is there to irrigate the countries, transboundary countries downstream, I guess, of China, is putting a large number of dams on the various rivers that go through their country. So yeah, it becomes an important and delicate, I guess, transboundary issue. What is someone asked a question, what is the time scale for your center in terms of, it will run indefinitely, run for 5 years? Is it funded by an agency? What are the mechanics of how your center will work?
So this center, this is a research initiative, and this is being seeded in 2 phases. So the first phase is for 2 years, and beyond that, if it succeeds, then we are going to have another 3 years. And once if the goals are again, satisfactorily achieved, then it can continue beyond. So there are goals that we have for each of these years, like for the first phase as well as the second phase. But it's currently being seeded by IIT Madras. But the goal is to also look at, other agencies, government agencies, such as the Ministry of New and Renewable Energy, the Ministry of Earth Sciences, etc., to see if we can get further support depending on the technologies and the science that we develop here.
So we're asking and answering all kinds of technical questions, but I'm sure the 205 attendees that I see still online might be potential students, and clearly I would think that your reason for doing this might be to be able to access that community. What should students think about this in terms of opportunities that might exist for them? What is the mechanism that they might probe opportunities that you might have for them if you're interested in being able to attract the very best students domestically and internationally?
Yeah. So we're always looking for interested students. As we had shown in the last slide of this presentation, we have a center email address, and we would request any interested student to reach out to us. And this could be an undergraduate student looking for a summer internship opportunity. This could be a master's or a PhD scholar, or a potential master or a PhD research scholar who are looking for interesting research areas. This could be a postdoctoral candidate, and all of them can write to us along with their CVs and their interest, and we are happy to engage with them. As as I had mentioned at the beginning of this talk, there are 14 faculty members. So we have a big group of people who are working in that area. So one of us is bound to have an opportunity that would be interesting to the student. So we would encourage them to reach out to us. In terms of career opportunities beyond their course program, as you can see, this is a highly relevant problem, and there are always challenging scientific questions that need to be answered, both in academia as well as in industry. So in my own experience working at national laboratories and in companies as well as in universities, I could say that there is never a dearth of complex and interesting scientific problems. I think, Professor Ellsworth, you have made a career of it, so you can probably answer that more than I can tell anything here. So you can give them more perspective on what kind of opportunities exist beyond their graduation.
Oh, you're asking me a question. Well, I'd say that people who are interested in this area are the true saviors of the future, saviors of the planet. I mean, I think I listened to many of my climate science colleagues, and certainly we now know exactly what is happening to the planet. We know it may be in quite dire circumstances, but our action to be able to work on it depends on being able to keep economies running. So action or no action is probably not an option. We have to do something, but in some kind of metered way. So I'd say that people who work in this area, the general area of energy, and especially in trying to reduce carbon footprints of energy, are really contributing something to how we move ahead in a positive way, rather than talk about the sky being falling all the time because of climate change. We are in a little bit of a pickle, so to speak, but I think there are great solutions, and it's only controlled by our collective will to be able to solve these problems, and to do it in an environmentally and economically viable way. And of course, the criteria for that are very different for different countries. So yeah, I encourage you to get involved. All kinds of opportunities domestically for you and overseas. I think if you're a young scientist or engineer, finishing with a bachelor's degree and looking at doing a graduate degree, then basically the world is your oyster. It's a great time. I wish I was 22 again. Perhaps I'd take a different path. Who knows? Anyway, so that's all I have to. So, how long should we be continuing this, Chandra?
Yeah, so I think as you can see, there is an endless array of questions. So I can understand that you are strapped for time. So if you have other engagements, please feel free to end. Yeah,
I didn't know what your thoughts were. Maybe we'll end on the hour in 9 minutes time.
Sure.
My hour, your half hour.
So the obligation was only 15 minutes and 15 minutes of Q&A, but there is a lot of interest, so we are going to get a lot of questions. Yeah.
Yeah. I like chatting to people. I especially like chatting to young people, and so that's great. So how can I, if I'm a physics student, can I still come? What's your answer to that?
Yes, I mean, as you can see, the work is very interdisciplinary, right? So all you need is an interest, right? So for example, computational mechanics was not what I majored in when I did my undergraduate studies, right? I majored in civil engineering, but computational mechanics is, it has applications in civil engineering, but it also has a lot of components which are not taught in traditional civil engineering. So you have to learn applied mathematics, you have to learn computer programming, right? So I would say that when you start doing research, these sort of silos that we think of subjects in, they vanish because things are related. So as long as you have good training in mathematics, you understand principles of mechanics, I think you are good to go. You know, you can think of a career in subsurface mechanics.
Yeah, I agree. People can switch disciplines all the time, and having some good background in solid principles of mechanics and physics in an engineering sense or otherwise is an important component. And I think you have to have some enthusiasm and interest and commitment to want to do something in that area.
Yeah, and I'd like to add that I know few scientists in Los Alamos National Laboratory who work on earth science and all this geothermal area. They had a undergraduate major in physics. So they're currently working on this problem, different aspects of the problem, and very successful. Yeah.
In fact, you know, in the US, we've had this underground geothermal experiment to characterize a small underground reservoir, which is in an underground former gold mine at 1,500 meters below the surface. And the idea is to test methods to develop hydraulic fracturing and linking, making reservoirs basically permeable that were not permeable. And the whole idea is you want to have the pre-existing stress applied, but you'd like to be very close to your experiment. And that experiment is in a former gold mine, which is now being used as an underground neutrino observatory for physics, the SURF lab in the middle of South Dakota in central US, of which there are many other labs around the country, around the world. And I would presume that India also has an underground physics lab as well, although I don't know its location. So yeah, so I think physics is a great background. How can I get an internship in undergraduate courses? Another question.
I would say please reach out to us with your CV, right? We would connect with you. We will learn of your interest, and we will provide you with potential areas where you can work in, and you know, we can maybe work something out.
Yeah, sounds great. Very good. So there's one question about solar power in terms of solar thermal. And so certainly in the deserts of California, there's Solar 1 and Solar 2. Actually, in 2000, maybe we went to see Solar 2 and it's already been decommissioned. But they rely on reflecting sunlight through a parabolic array onto a tower that has salt in it. The array melts the salt, and you then use that salt to transfer heat to generate power just using a closed circuit with steam. So does any such plan exist for India to be in the middle of the country where I think it's super hot, right? Away from the edges where these transboundary problems exist that you've kind of alluded to in terms of hydroelectric power. So what's the prospect for something like a solar thermal in the desert areas? So what, I guess it's the Deccan Plateau, right? Super hot, super dry, or not?
I think most of India is super hot and super dry, but I can.
Except for the monsoon.
Yeah, so I think we have some massive solar plants which are being developed in this part of the country, which is the western edge in Gujarat. I'm not the right person to talk about them because I don't have the expertise. I haven't kept up except for reading newspapers about it, right? So if anyone else on the panel knows more about it, I welcome them to discuss them more in detail.
I bet you everyone's going to keep their head down. So here's another question. What about nuclear fusion? Not fission, but fusion. That's gaining interest worldwide. I think it used to be the sole domain of activities for countries to get involved in. The Triumph project in Canada, at UBC, and the ITER problem, I think originally at Oxford and now in France. But now I think the public domain, the private domain, and private sponsors are beginning to get involved with more innovative ways to do it at smaller scale. And so the prospects of fusion as kind of an unlimited source of power, although kind of a long way off, is perhaps a real possibility. Any comments on that?
I'm not aware of any such research initiative in India, primarily, I guess, due to the cost that is involved, right? So when I was at Livermore, although there was a whole facility which was trying this, and they've been trying this for a few years. They are successful, but not, in any meaningful way. I think there is a national ignition facility which has been trying. It's a very hard problem. So given that, United States has a lot more resources that they can allocate to this problem, I don't think that India is currently, has that kind of strength to actually go and explore this problem. So I'm not aware, not sure that it is in the pipeline as well, but we never know.
Yeah.
Chandra, I just want to add one. Sorry, I just interrupted. So in the part of ITER collaboration, which is now coming up in the France probably, so that is like a $53 billion project and no country, single country can support. So in the part of that collaboration. Thanks.
Yeah. So you're part of the sounds great. Sounds like the way to do it. I think on big projects like that, you have to collaborate. So that makes good sense. Well, fantastic. So I think we're coming up. We have 54, 53, 52 seconds left. So I think maybe we'll wrap up by thanking the two speakers today. For Chandrasekhar and Ramesh for their great presentations. I think it's clearly stirred a lot of interest. It's dwindling now. We're down to 135 from a high of low 300s, I think, which is a great indication of interest in this general area, and this is a great way, I think, to be able to broadcast your new initiatives. And I'm very excited to be able to follow what the center is doing. And I look forward to receiving my plane ticket sometime in the mail, and I'll come out to visit. Thank you very much, all you panelists, for being online. Thank you very much for the speakers, and that's great. Thanks very much.
Thank you so much for agreeing to moderate and spending so much time with interest on all these questions. And we are ready to get you a plane ticket, if you're ready to travel. There is absolutely, I think we would love to have you in IIT Madras. I think, and like you said, you visited Chennai, so there's a connection. So it would be our pleasure to host you. Yeah.
I'm sure that'll happen sometime. When's the best season? When I was in Chennai, it was March, and it was quite pleasant, actually.
Okay. I think, maybe October to December, it's like, we have intermittent rains here, so it's a little bit pleasant. So I think that's probably the best time, but I'll probably defer this question to the local Chennai, Chennai local residents. Ramesh, would you like to take that?
Of course, I think like October to December is the nice season here. So probably like next time when Derek is here, we will try to invite him or take him to different places. Now, of course, Chennai, last time when you visited, probably it's completely different. It's 90s, right? 94, something like that. So
it was 94, yes, I think it was 94, March of 94. And I went briefly from the center of Chennai to stay in the valley for a couple of days and then came back. So yeah, I'm sure it's very, very different.
It'll be
anyway, I'm not pushing my way into your lives, but that'd be kind of cool. I'm sure we'll do that one way or the other, and if not, we'll meet you all individually somewhere around the world. Thanks very much.
Okay. Yeah. Thank you. Thanks.
Thank you, Professor Ellsworth. Yeah.
Take care. Great. Bye-bye.
Bye now. Yeah.
Bye-bye. Thank you so much.
So yes, Professor Chandrasekhar. So I hope we have covered maximum every questions. So if you allow me, I can formally close the session.
Yeah, I think that'd be fine, and we're happy, to individually answer any further questions that are still open, right? So people can feel free to reach out to us on our emails, the center's email, and we'll be happy to engage with them.
Sure, I think you can put in the chat box, the email ID, so that they can be.
Yeah, I'll do that.
Because usually we also get a lot of questions from the audiences that how to join the lab, like for an internship or for a work.
Yeah.
And maybe this could be a possible gateway for them.
Sure. Yeah, they could just email us their CVs, and we are happy to engage with them. Yeah.
Sure. Thank you, Dr. Chandrasekhar, and thank you everyone on the panel for making this session even very much wonderful. Thank you, audience. Please note down the email IDs that has been put out in the chat box so that you can reach out if you have any other doubts or clarification regarding this particular webinar. But if you have any common questions regarding IOE or the entire webinar series, please feel free to reach us using the website ioe.iitm.ac.in. Thank you once again. Looking forward to meet you in the next webinar. Thank you.
Yeah. Thank you, Rudra.
Thank you.
Thank you.
Thank you.
Ms. Lisa,
Bye-bye.
please proceed for the closure.
Thank you all.